Hi, this is Paul. We're doing Leetcode must know interview questions. Today's challenge is construct binary tree from preorder and inorder traversal. Given two integer arrays, preorder and inorder, where preorder is the preorder traversal of a binary tree and inorder is the inorder traversal of the same tree. Construct and return the binary tree. All right, well, let's see what that means. If you just have, if you just had one or the other, there's any number of ways to construct a tree. But if you have a preorder and an inorder traversal, there should only be one way to do it. So let's first talk about what is a preorder traversal. Preorder traversal is root, left, right. So preorder means if we have this tree, the example 1 tree, we would start with 3, and I encourage you to look at this as we go. But we would start with the 3, then we would go to the left subtree. The only thing over here is a 9. After that, we can go to the right subtree. And again, we go root, which is 20, and then left, which is 15, and then right, which is 7. All right, that's a preorder traversal. Now here is the inorder traversal. Inorder traversal is left, root, right. So for this tree, we would start here and we would go left and get 9. We go back to the root, we get 3, and then we go right. But now we've got another tree, a subtree, and we process that in the same way, left, root, right. So we first go to 15, and then we go to 20, and then we go to 7. All right, so that is the inorder traversal. All right, let me see. Whoops, I need a pen here. Let's see if I can talk through what we're going to do here. First thing we're going to go through is the preorder traversal. Preorder again is root, left, right. So the first node in the preorder traversal is going to be the root of the tree. And the first node is a 3. So we'll put that at the root of the tree. Okay, and then we'll find the 3 in the inorder traversal. And the 3 in the inorder traversal is right here. Where'd it go? It's right here. Now, in the inorder traversal, everything to the left of that root node is going to be in the left subtree. Everything to the right of the root node is going to be in the right subtree. Okay, the left subtree is pretty simple. The preorder traversal tells us that the next node that we want to put in the tree is a 9. The only node in the left subtree here is 9, so that is going to go right here. 3, 9. All right. Next node in the preorder traversal is 20. Okay, find that in the inorder traversal, and it is right here. The inorder traversal tells us that that is going to be the root of a subtree, and everything to the left of it that we haven't already processed is going to be in the left subtree. Everything to the right is going to be in the right subtree. That means that 15, oh, you know what? Let's go ahead and put the 20 in. 20 is going to be the next node that we add to the tree. Everything to the left of the 20 that we haven't processed will be in the left subtree. The only thing that we see there is 15. Again, we add that to the tree. That is the next node in the preorder. The next node in the Inorder is 7. 7 is here. It's in the right subtree. So we can go ahead and add it here. All right, so that looks like the tree that we were trying to get. The hard part about this is creating a method where you can accurately keep track of where you are in the preorder and in the Inorder. And what else? I think that's it. I think we're going to need to create a recursive method where we can pass in, all right, this is where we're at in the preorder, this is where we're at in the Inorder, and we'll also need to pass in the size of the subtree, I think. But let's go ahead and try an implementation. All right, the first thing that I want to do, let me give myself a little bit more space here. First thing that I want to do is add a couple of variables to the solution class. One is going to be int array. We really don't have to have this. Preorder traversal. What is this thing called? Okay, it's called preorder. Preorder traversal. That's just going to hold a copy of this preorder array so that we don't have to pass it to the recursive function every time. I mean, we could pass it to the recursive function and not define it here, but I mean, it's programmer preference, I guess. But I'm going to define it here as a class variable. And the other thing that we need, and again, we don't really have to have this, but it's going to be a map. It's going to map the values in the Inorder traversal to their indices in the array. So we can just do an O1 lookup. When we get a node, and we can do this because one of the constraints was that the nodes are, the values in the nodes are unique. So this will work. We're going to map the value of the node to the index. So we can just do an O1 lookup and go right to it. I mean, we could go through the array and find it, but it's going to be better if we can just do a lookup. So we'll call it Inorder indices, and that will be a new hash map. Okay. Okay, let's do build tree. This could be our main function, but we're going to need to write a recursive function as well. We're going to use this multiple times probably, so I'm going to just instead of typing every time, I'm going to put it in a variable. N is the length of our input arrays, and we are going to get the preorder traversal. This preorder traversal equals preorder. Again, this is just so we don't have to pass it into the recursive function every time. All right, let's fill out the hash map for int I equals 0. I is less than n, I plus plus. Inorder, what did we call that? Let me just grab it here. Inorder indices dot put, and we are going to put Inorder I. We're going to put the value and the index. All right, we're going to map values to indices. All right. And finally, we are going to do this, return, and we need another method, and we'll call it build tree recursive. Before I fill in the method, the parameters there, let me do this. Let me say private tree node build tree recursive, and I'll show you what the inputs to this are going to be. We need the index. We need the starting index. Well, I don't know if it's the starting index. We need the current index. Where are we in the pre-order? What do I want to call this? Let's call it pre-order index. Let me think about this for a second. Okay, yeah, I think that'll work. We'll call it int pre-order index. We are also going to bring in int in order. In order index, and we are going to bring in the size of the tree that we're going to build. All right, that's it. So on the initial call to build tree recursive, we are starting pre-order index. We haven't done anything yet, so it's 0. Starting at 0. In order index, again, we haven't done anything yet, so it is 0. And the size of the tree that we're going to build is n, the length of the array. We're going to build the whole tree. Okay, down to build tree recursive. The base case for this recursive function is if the size gets down to 0, then we're done. Return null. Okay. Root value. The root value of the tree. Again, when we went through it by hand, the nodes go into the tree the same order that they're in the pre-order traversal. So the root of this tree is going to be, root value is going to be what did I call it again? Yeah, pre-order. You know what? I should capitalize that. Well, you know what? It's too late now. Okay, let's just use this. Is pre-order traversal. Yeah, see, now I don't like it anymore. All right. Let's lowercase it then. Just so they're all the same. Pre-order traversal, pre-order index. Okay. That means the first time through, the pre-order traversal array, it starts with 3. So 3 is going to be the root of the tree. All right. Next, int in order root index. That means, all right, now we've decided that the root of the tree is going to be 3. That's where we find the 3 in the in order array. And we can do that using the hash map. In order root index equals in order indices dot get root value. Look up the 3 and get the index. And the size of the subtree that we're going to build, the left subtree, we already have the root value. We're going to go to the left subtree. The left subtree size is going to be the in order root index minus in order index. All right, what does that mean in our example? Well, what it means is we decided 3 would be the root of the tree. We found 3 in the in-order array. The index of that is 1. All right, in-order root index is 1. In-order index that we passed in is 0. It's right here. Whoops. Right here. And so the size of the left subtree is going to be 1 minus 0. 1. Okay. I guess I can leave it like that for now. What's next? All right, tree node, left subtree equals, I'm going to do a recursive call here. Build tree recursive. What are we sending in here? We're going to send in preorder index plus 1. Again, the nodes go into the tree in the order that they are in the preorder array, so the first node in the left subtree is going to be preorder index plus 1. It's going to be the 9. The in order is going to be, again, the in order is still going to be the in order index. We haven't really done anything with in order yet. In order index and the size, this is going to be too big. Let's do it like this. So return it here, space it over to here, and, oh, okay, that's fine. And size is going to be the left subtree size. Okay. Right subtree, tree node, right subtree equals, again, build tree recursive. What's going to go in here is going to be, where does the right tree start? So the right tree is going to start at preorder index plus 1 plus the left subtree size. Didn't fit. I can fix it. All right, left subtree size, comma. Is that right? The left subtree size in this case is going to be 1, so the right subtree is going to start at preorder index, which is 0 plus 1 plus 1, so that's 2. So it's going to start right here at, I mean to do the whole thing, but it's going to start at 20. 20 is going to be the start of the right subtree. Okay. And let's move this over. We need, let me think about this one for a second. Okay, so what we need for in order is we need the first node in, we need the first node that's going to be in the right subtree. And in that case, it's 15. That doesn't mean the root of the tree. It means the first node that's going to be in the right subtree. So first thing we did was find 3 at the beginning of preorder, so that's the root of the tree. Find the 3 in order, and then we can split in order and say, all right, everything to the left of that is left subtree, that's 9. Everything to the right of that, that's 15, 27. That's in the right subtree. So we are going to start at 15 for the right subtree. And how do we get to that? That is in order root index. We have in order root index, in order root index, which is 1. It's the index of this 3. So we can go from there plus 1. That'll take us into the right subtree, and the size of the subtree is going to be the size. This is when we passed in, it was 5. It's going to be size minus 1 minus the left subtree size. Okay. Left subtree size. All right. Size minus 1 because we've already used at least one. We used one node as the root of the tree, and then the left subtree size. So subtract 1 from the root, subtract the left subtree size. That'll give us the right subtree size. Okay. Put that. Move this over and do that. What are we going to return from this? All right, so we're going to recursively build the left subtree and the right subtree. Okay, actually, as I'm looking or thinking about what I want to return here, I notice that something is wrong here, like line 36. Why is everything white? And that is because that should be an equal sign. All right, is there a constructor here? We need a constructor with a value. Yeah, this one right here. A value and a left subtree and a right subtree. So that's what we want to return. We are going to return, let's see, return new tree node. We have a root value. It's right here. So we'll return the tree value. We'll return the left subtree and right subtree. We could walk through the recursive building of the subtrees. I'm going to leave that as an exercise for the viewer because it's going to take too long. But I think this should work, except we have like a stray parentheses here. I don't like that. What would happen if I just took it off? Private if. All right, is there a missing parenthesis somewhere? That looks okay. That looks okay. That looks okay. I'm going to leave it like that. All right, I'm going to leave it like that and run it and see what happens. Compile error. Yeah, that isn't going to work. I++. The other compile errors. Is it all in the same thing? Oh, missing semicolon. Okay, put that. Let's go one more time. All right. Basic test cases pass. I feel like if the basic test cases pass, that really the whole thing should pass. All right, good. Runtime, let me scoot that over a little bit. Runtime is good. Memory, I don't know, not so good. You have to do this. You don't have to do this. You don't have to do this recursively. So probably, there's some memory issues regarding the recursive stack. Oh, you know what? There isn't so much really. It's all very close. Okay, so that's it. What was this called again? It's a long time. I don't want the submissions. I want the description. Construct binary tree from preorder and inorder traversal. Okay. I hope you enjoyed that, learned something. Feel free to like, subscribe, comment, and see you next time.